Okay, that's oh, some people has not come back yet. Hopefully. Okay. Any question up to this point of time? Okay, if there's no question, let's carry on. Okay. So, now, so as I mentioned, most of this clustering scheme, this clustering technique, we kind of like map the subject that we want to group into a multi-dimensional space, right? So before we do the mapping, actually the first thing we want to do is we want to do a scaling, right? What we mean by scaling is we want to standardize the variable. Take this example, take this chart example again, right? Because we are mapping the subject with their variable value into a space, right? So now, if for example, if this x1 variable, their value is like between 0 and 1, right? And the x2 variable, its value is like, it can be up to several thousand or several millions, right? And so x1 is, the scale of x1 is like kind of like very small, and the scale of x2 is like very large, right? And in that case, when we map, if we directly map that two variable into a space, right, the distance would be kind of like dominated by the variable that has a very large scale, isn't it? Right? The x1 is become not important when we are doing this clustering, and that is not desirable, right? Desirable. If we want to have that every variable have the equal importance when we are doing the clustering, the first of all is there is a technique we call it scaling, right? Normalize or scaling, right? So we can like change the scale so that the scale of all of this clustering variable, this grouping variable, are standardized, right? Okay. Those who already study statistics should know what is standardized, right? It means that it kind of like transform the value of the variable so that their average is becoming 1, and their standard deviation is becoming is also sorry, their average will become 0 and their standard deviation will become 1. Okay, so after doing that, now every variable, okay, have the same scale, so that when we do the mapping, we can calculate the distance correctly, right? So the first step of doing the clustering is actually doing scaling, right? But And then after we do the scaling, we map the subject into the multi-dimensional space. We need to calculate the distance, right, between each of this subject, so we can do the clustering, right? We want to have a subject that stay close to each other, so we need to calculate the distance between them, right? Among them, actually. And then we can apply the hierarchical clustering algorithm so that we can group the subject within that multi-dimensional space. We can group the closer subject into a same group, okay? And then after we do this algorithm, the outcome will be a dendrogram, which means that actually let's take a look at this line of code. Okay, now in the beginning, for simplicity, I try to use like just two variables, right? 3 and 4, which means I'm using flesh and milk. Just use two variables for simplicity. Okay, so you just put the data, and in R, when you want to do scale, you just call the scale function. Okay, you want to calculate the distance, you just call the distance function. You want to do the hierarchical clustering, you simply call hierarchical clustering, right? So you don't really need to worry about how to do that. Okay, every step is actually just a simple function call. Okay, and then you can pipe them together, and after you give the data, process the data into this pipe or function, then it will actually produce a hierarchical clustering object, data object. Let's take a look at it. Now, after we do this, we will have a hierarchical clustering data object. Okay, and if you plot this data object, say we plot them. Okay, if I plot this data object, I will have a so-called dendrogram. And that's the you will see a plot like this. Okay, if I plot, you will see this dendrogram. This is called dendrogram. I'll explain that later. Okay, don't worry. And then you can cut this dendrogram into different groups. Okay, this is actually at the bottom of the dendrogram is the 440. Is this 440 retailers? Okay, and every horizontal bar is actually a group. So in the beginning, you don't have group. So in this group, all of the 440 retailers in this group. Okay, and then this hierarchical clustering, they divide the group it divides the entire group into two groups, okay, according to their adjacency in the multi-dimensional space. And then in this group, it divided into two groups again. This group divided into two groups again, right? And in this group, it divided into two groups again, right? So you will repeatedly do this. So so in the beginning, there is only one group, and then you would have two groups. Okay, that's how we call hierarchical clustering. Okay, because it's kind of like hierarchy, right? In the beginning, everyone is in the same group, and then they divide it into two groups, okay? And then each of this subgroup, they divide it into two groups, and when you repeat this process, it can kind of like separate the, like they can kind of like divide the population into group of different sizes, okay? Okay, but this is not finished yet, because the next thing we need to determine is how many groups do we want to divide, right? So you need to cut this dendrogram. For example, when I do this, if I want to divide them into 6 groups, I can actually cut the dendrogram, right? Here, if I cut it here, so I will have like 1 group, 2 group, like 3, 4, 5, 6. It's a little, okay. This is 1 group, another group, and this is 1 group, right? So we have 1, 2, 3, 4, 5, 6. Okay. If we cut the dendrogram here, we only have like 2 groups, right? If we cut the dendrogram here, we have 3 groups. If we cut it here, we have like 4 groups, right? Let's see it here. Maybe it's easier to see it, right? This is a dendrogram, right? So if I cut the dendrogram here, I will actually only have 2 groups. But if I cut it here, let me like put a line here, so it's easier to explain. If I cut the dendrogram this way, then I will only have 2 groups. But if I cut it here, I will have like 4 groups, right? And if I cut it here, I will have how many? 1, 2, 3, 4, 5. 5 groups. Okay? So now there's a question that how many groups is optimal, right? It will be a question. I will hold this question later, okay? Now, but the thing that I want to explain here is like, actually this dendrogram, you want to plot the dendrogram is easy, okay? You simply call the plot dendrogram, then you will have a dendrogram, okay? But how to interpret the dendrogram is what I want to explain here, right? Okay. Actually, the horizontal bar represents the group that I already mentioned, right? And the height of the horizontal bar, it represents the average distance to the group center. Let's take a look at here, right? This is the group center, right? And this is a group center, okay? Okay. If I and the height of the vertical bar is actually let me say it again. The height of the horizontal bar represents the distance, the average distance to the center of the group. Okay, height of the vertical bar, horizontal bar, it actually represents the average distance to the group center. So if I only if I put all of the subject in a single group, the distance to their the average distance to the center is like longer, right? But if I divide them into 2 groups, right, in this case, then you can see that in these two groups, their height is much lower than this one group, right? So simply by divide one group into the two groups, I actually reduce their distance to the centers about 50%. Okay, so that is what the mathematical algorithm do for you. Okay, it would automatically search for the group that stay together. So when they divide this one group into the two groups, the distance to the center of the group reduce. Okay? Okay? And you will repeat this algorithm again and again. Okay? So in this way, the more group that you divide, the smaller distance they were the subject to the center of the group were be reduced. Okay, so as we can see here, if I divide it into like 5 groups, this is the case, right? So for example, if I divide this yellow group into 2 other groups, then you can see that, for example, and this new group will have like they will stay closer, right? Right. The more group that I divide, the closer the subject will be closer to each other, right? And which means that they are more similar, right? Because the distance is actually represent the difference, right? So if they stay closer and closer together to their group center, it means that they are more and more similar, right? So there's a trade-off. If I divide the subject into a lot of groups, for example, I put it here, I would have like maybe more than 10 groups, okay? And the members within this group are actually more similar. But actually, too many groups would be more difficult to manage, right? Isn't it, right? You need to design a management scheme for each different group, right? So too many groups is like it will become more difficult. You will spend more effort to manage, right? But the more group will have a more similar subject, right? So there's a trade-off, right? Similarity and the number of group, okay? The more group that you divide, the more similar the subject are within a group, right? But you will need to spend more time to manage group because you have more group to manage, right? So that is kind of like a trade-off. So there's no standard answer for how many groups you want to do. And later on, I will explain to you how to choose the right number of groups. Okay? So far, let's go back to the. So this is the how the hierarchical clustering is due, right? It sounds like a pretty lengthy, pretty difficult thing to do, but actually in R, as I told you, that you can actually use although there are a lot of steps, but you actually can group all of this step into a single data pipeline, right? So when you want to do a clustering, what you need to do is like you can do it this way, right? I can actually combine the two pipelines together. When you cut the dendrogram into groups, you basically call this cut tree function, and this is the dendrogram object, right? And this is the number of groups that you want to divide, right? And usually we were transfer it into a factor, because and then after we do this, we simply create a new. For example, if we divide it into A group, right? Then here in this W data frame, we can create a new column to put this group number. Okay. So after we have this dendrogram, we can cut them into like A group. Here you will see a group column. Okay. So now every retailer will be divided into a group, will belong to a single group, right? And if we want to see the size of each group, we simply do a table, right? And see, this is the first group have 117 retailers, second group 69, right, and so on. Okay. In this case, the eighth group only have one, right? So basically, you don't like to have the group so small, right? So usually I would, when I see this, I'll try to maybe reduce it to 6 groups, and then do the table again. Now the grouping is still like it's always this way, right? Some group will be large and some group will be small, right? Depends on how many groups you want to cut it, right? You actually can combine the entire process together, right? If I do this and put it here, right? So this is the data, and we do the scaling, we do the calculate the distance, we do the hierarchical clustering, and then we cut it into 6 groups, right? And then I put the entire thing into like. So if you want to do hierarchical clustering, all you need to determine is which variable you want to use to do the clustering. And the second thing you want to determine is like how many groups you want to divide. Okay? You don't really need to like take a look at this dendrogram or whatever. Okay? What you need to do is like kind of do this pipeline and then maybe do a table to examine the result of the grouping, right? That's all. Okay? So the reason that we say that clustering is advanced analysis because that it really take a lot of steps, right? But as I show it here, right, all of this step is actually just a function call in R, right? Okay, so all you need to do is like if you like treat it like a assembly line, right? And you just call this series of functions. And you only need to do is like you select the variable you want to use for clustering, and then you determine the number of groups that you want to divide. And then in R, you only just like use this 2 lines of code. You can actually divide the group, right? And then you will have a column in your data frame telling you that which retailer belongs to which group. Okay? So doing it is easy, actually. Okay? I just want to let you know the logic behind the clustering. Okay? So any problem so far? So this is clustering. Okay? And this is how we do clustering in R. Okay? A lot of steps, but don't worry about that, because I can actually chain everything together and then like do it very easily, right? And the second thing is like we can actually, we have the group, right? So use ggplot, we can do a scatter plot, isn't it? So because right now I'm grouping them into 6 groups, right? So we will have 6 groups, and then you can see that in this space, the similar, the closer point will be grouped into a cluster, and because they are closer in this space, it means that their variables are very similar, right? Okay. So you can have the group like this one. Okay, so this is the a simple example. Okay, but right now I only use in this case I only use 2 variables for the clustering, right? But in reality, we might want to have all of the product category, right? I can use all of the product category to do the clustering. Okay, actually, you don't really need to plot this HC dendrogram. It's only for like explanation purpose. Okay. In practice, usually I will simply do this, right? I will simply do this 2 lines. Okay. Instead of plotting and cutting, usually I will simply do it this way. In this example, I only use two variable, right? I'm using variable fresh and milk, right? If I want to use more variable because I want to use like this, then I can like change it into like 3, 7. Okay, so and still we want to group it like 6, right? So you simply do this. Now it's no longer a two-dimensional space, right? Because right now you have 5 variables, so it becomes a 5-dimensional space, right? But 5-dimensional space is very difficult to visualize, isn't it? Right? When you only have 2 dimensions, right? It's like when you only have 2 variables and 2 dimensions, it's easy to do the visualization, like we have done here, right? But the problem is usually you will have a lot of clustering variable, right? And when you have like 10 variable, you kind of have a 10-dimensional space. It will become very difficult to do the visualization. Okay, and that is why we need to do dimension reduction. Okay, when you have like 10-dimensional space and you want to visualize them, okay, you cannot like draw a 10-dimensional space. You cannot imagine that, right? Okay, so we have another multivariate statistical technique called dimension reduction. Okay, let's see how we do it first. Okay, say we have like this all of this 1, 2, 3, 4, 5, 6, all of this 6 product category, right? And we want to map, okay, we want to map the subject into this 6-dimensional space. Okay, you cannot do that directly, right? Because the 6-dimensional space, how can you visualize it? You cannot, right? So you need to compress the multi-dimension into a lower dimension space. Okay, let's see the result first before we do the explanation. Okay, to do that, it's actually quite easy. Okay, to do dimension reduction. Okay, let me switch to here. It's easier to see. To do dimension reduction, actually in R is quite simple, right? Okay, you simply give them the data, right? The data is in this 6 column, right? Okay, so you put the data in the beginning of the pipeline, and you call this capital PCA function. Okay. The PCA function would do the principal component analysis, which is one of the major dimensional reduction technique that we use, right? Okay. So after you do the PCA, usually I will suppress the graph because its graph is like very ugly, right? Okay. So I will use this visualization tool to help us do the visualization, right? And it's even I use this visualization tool, it still does not look good, right? At every subject, right? We have 440 objects, right? It will become a point, okay? And as I told you that we will have a total of 6 variables, right? So it kind of like this PCA function, it compresses the 6 dimension into 2 dimension. Okay, so at the first, now the first component and the second component, they would, it's kind of like you know, watermelon. The watermelon has seed in the watermelon, right? So watermelon is a 3D object, isn't it? Okay, it's 3-dimensional object, and there are seed within that. It's like a high-dimensional space with a lot of subject within that space. Now, if you compress the watermelon into 2 dimensions, okay, you compress them. The seed is also will be placed into a point in a plane, isn't it? You compress a 3-dimensional watermelon into a 2-dimensional plane. Every seed is still on that plane, isn't it? Right? Now, this PCA technology, it will kind of automatically search for a place. So when you compress the space, the information loss will be minimum. When you compress the high dimension into low dimension, some information will get lost, right? Because in the beginning it's 3-dimensional, you have 3 variables, right? So after you compress it into a 2-dimension, you will have only 2 variables left, right? So you kind of like this dimensional reduction is basically just compress the information within the 6 variables into 2 variables, okay? And during this compression scheme, we try to minimize the information loss, okay? That is the basic idea, right? There is a mathematical algorithm, try to find an angle, try to find a way to compress the information within that 6 variable into the 2 dimension, okay? Into the 2 variables. And this algorithm will help you to preserve as much information as possible when you reduce the 6 variable into 2 variable, right? That's what we call dimension reduction. The reason that we want to do dimension reduction is now we can plot the variable and all of this subject in a 2-dimensional space, even. Okay? Here you can see that this is the information remains. Okay? So, in the beginning, in the 6th column, we have 100% of information. Okay? But after compression, as you can add it up, like here we have like 44 plus 27. This is like kind of like 70%, right? Okay, it's not bad, right? When you originally have 6 variables, and all of the information is in these 6 variables, when we compress it into 2 variables, okay, we still have 70% of the information remains in that 2 variables, right? And the advantage is that we lost 30% of variable, but we can actually plot the variable and also the data point in the two-dimensional space. Okay, and this is pretty ugly, right? So actually, if you put some option in this function code, this is the same function code as this one. And in this case, I do not give it, I do not specify any options, right? And here I actually specify a lot of things. For example, I specify that the color of individual I will use would depends on this group. Because we already cluster them into 6 groups, right? So the individual point, the color of individual column will depends on group. And also I want to put a label on the variable name. Okay, so this is the 6 variable. Okay, and then I also specify the point shape. I suppress the mean point. Otherwise, you will have a mean point here in each group. Okay, and I also specify that I want to use the convex. I want to draw a convex line on the border of each group, right? And this is just to choose the color, right? Okay. I don't have too much time, so you can see the detail of this function code if you like to. Like you can, like, as I told you already, right? Press the cursor on the function code and press F1. Then you will see online help of all of the variables, and right? Okay. Basically, you can use my setting as example, and if you do not like the color or you do not like whatsoever, you can do the adjustment. Okay. Now in this way, we actually have a very nice idea about how this 440 retailer, and when we group them into 6 different groups, right? And this blue group, as you can see that they buy they buy less. In this direction, it means that if the point is in here, it means that the retailer buy more milk, grocery, and detergents. Okay. If the point is here, it means that it buy more deli, buy more fresh and more frozen food. Okay. So every point is actually corresponding to each one of the retailer, right? And its position in this space, okay? And because we already have that, we compress this 6 variable into this 2-dimensional space, okay? So you can very easily see a few key things, right? Okay? Say, when this variable, they are in the same direction, it means that this variable tend to have higher correlation, right? It means that the first thing that you can read out of this chart is that there are correlation, okay? There are correlation among these variables, okay? That's why we can compress them, okay? So when these 3 variables are together, it means that the retailer that might buy more milk tend to buy more grocery and tend to buy more detergent. Okay, and this 2 is like has a very small angle between them, right? it means that the people who buy, the retailer who buy more frozen food tend to buy more fresh. Okay, and actually the angle is larger, but it's basically on the same direction, right? So the retailer who buy more these two category also tend to buy more this thing. Okay, so and we know that because this blue group is here, so this group they only buy a very small amount of milk, grocery, and detergent, right? This is the characteristic of this group. And this group, they kind of buy, this yellow group, it's kind of buy, it's kind of like the average, right? You buy every product like, kind of like, do not have a very specific preference across the product category. Okay. How about this group? This group actually it buy more milk, grocery. These three group they buy more milk, grocery, and detergent, right? But among these three group, the green group, they buy more milk, grocery, detergent, but they buy less deli, fresh, and frozen, right? Okay? So combining the clustering and dimension reduction skill, okay, by combining dimension reduction and also the clustering skill, we actually can like we actually can visualize a large data frame with a lot of row, right? In this direction, they are reduced into group with similarity, okay? And in this dimension, we actually can compress a lot of variable which map to a multi-dimensional space into a two-dimensional space, okay? So that clustering is actually do a compression do a classification in this direction, okay? Clustering is actually looking for similarity and divide the subject into groups. And dimension reduction, what it do is actually it helps you to compress the information in a high dimensional space into a lower dimension, so you can see the characteristic of each group in a clear picture. You get the point now? Okay? So after we apply these two schemes, the first thing is that we can see the group, and we can see the group characteristic, right? Okay? So so this is the clustering and dimension reduction skill that I would like to introduce to you today, right? You may not have much time to apply them to your midterm yet, right? But it's important to understand these two skills when you, if you have chance to do some advanced data exploration, because nowadays the business data is becoming larger and larger, which means that you will have more and more data the data records, right? And you will have more and more variables, right? So in this environment, when you want to like group the subject according to their similarity, and you want to like represent them, you want to present them in a graph, so that you can tell the different characteristic of each different group. Then you use this two technology, okay? Which is clustering and also dimension reduction. Okay, so it's 11 o'clock. Let's take a break, and then I will give you some interesting example, so you can kind of like appreciate how to use this. Usually, how we apply this technique in the business circumstances. Okay, let's go back at 11:10. Okay.